Hello everyone, good morning, and thanks for coming to this talk. How many of you are excited about knowing how to do networking for containers? All right, cool. So rest of you, get interested now because that's what we're going to talk about 45 minutes. If you don't want to hear about containers and networking, here's probably the right time to exit the room. So my name is Narayan Annamalai. I'm a product manager in Azure Networking team. I lead the product group for SDN, which mainly involves virtual networks, load balancers, IP addresses, and ACLing and all that. And I'm joined today with Anand, who's, you're not seeing the screen. That's because I have to switch it. All right. Yeah, so I'm joined with Anand today, who is actually a product manager working on containers. So this will be our agenda today. So we really want to demystify, if there's any doubts on your mind, how to use the network in Azure for your modern applications which are using containers. How are you going to do that? We'll talk about the Azure CNI plugin, which actually is the fundamental way by which we provide networking for containers. And then we'll talk about a few announcements. We're actually announcing VNet integration for ACI, the Azure Container Instance, and web apps. We'll talk about that. We'll show you some cool demos. So the goal of this session is to make sure that you leave with the knowledge of how to plug in your containers and your modern apps into your existing VNets and how you can use them effectively for the things that you naturally do with your IaaS workloads, right? So one thing to notice is that there's a changing a wave of things that is actually changing right now with respect to networking needs. The apps are moving to the cloud. It used to be just lift and shift, where whatever is running on-prem, you move to the cloud, and those came in as VHTs or VMs because they didn't change much. But now we start to build new apps that is actually cloud native that you want to run in the cloud. When you do that, you look at the modern technologies. What is there that you need to be building against so that you are future-proof? And with that, there's a clear thing that's going on that these applications has to be very dynamic in nature, built in small units so you can deploy them and update them faster. So the containers are the right way of doing that, where these are really, really small units of your code or app which can be distributed easily and can be brought down or brought up very, very fast. And think about the compute moving to the edge. That's the concept where the edge is becoming more intelligent, right? The intelligent edges are going to have a lot of these small containers running in them, which you can mix and match to bring powerful scenarios to life. So that's the way the future is going with. So what's the container about? I mean, it's really one slide for basics. Now, what is this container really, right? I mean, we were in phases where a traditional virtual machine is something that we virtualize the hardware. So we had the same hardware, same physical server, but different VMs. Each of these VMs had their own OS, own operating system, which means they had their own network gear, network interfaces. They could see all that. Now, when we move to containers, these are just applications. These are just processes that is running inside the same operating system. So they don't get to have their own networking interface that's connected to the physical network. So they are more so using the operating system. All the apps in a given VM are using the operating system. And some fun facts, right? The average lifetime of a container is 2.5 days. Most practical use cases are less than that. The containers are meant to be brought up and then brought down. As soon as your job is done, they're out, they're dead. And then you bring them back up whenever you need them. It's not like your VMs, which are always there for you to log into and do stuff. And that's the whole point about being more efficient, being more cost controlled. And that's the benefit of containers, is that they're very dynamic in nature. They come up and they go up, they go down. So which means that we in Azure are providing a lot of different ways in which you can modernize your apps. So, and there's nothing secret over here. I mean, almost the very general, what everybody uses for container technology is Dockers. So you have an app, you containerize that into a Docker container, and you store that app in a Docker hub. But when you come to Azure, we give you an ACR that's called Azure Container Registry, which can save your Docker images into. And then we give you a lot of different orchestrators to kind of build your apps. So app service is one of a service that you can use from Azure, which uses container-based architecture inside that to actually run your websites. You can use Service Fabric if you're doing Windows containers. They also support Linux now. You can use something like AKS, and the latest is ACI. These are all different orchestrators that makes it easier for you to run your container workloads. We also support like other third-party orchestrators, Docker Swarm if you want to use, OpenShift, Mesosphere, all that runs in Azure, right? So what we're really doing in this is we're providing the infrastructure and the tools that you need to run containers, okay? So this is all great from a compute standpoint, but what about networking? Because if I'm going to give you a different solution for networking with each of these orchestrators, you'll be scratching your head. You will not know how to use them. You will not know if you can take dependency on these. So what we are doing on the networking side is we have a few principles, which is we want to provide a unified networking stack for all workloads in Azure, right? And this is a momentum behind bringing everything into the VNet as well. So if you have seen in the past, we provided VNet and SDN for traditional IaaS workloads. If you had a virtual machine scale set, then you were able to put them on a VNet. You had a NIC. You can do network security groups. You can do public IP addresses. You can do load balancing. You can do route tables. All worked great for IaaS, right? But the minute you went into PaaS, like if you're using Azure Storage or Azure SQL DB or Azure Key Vault, you don't have the same networking abilities to play with. So, and you know that we have started to bring all these PaaS services into the VNet. So VNet service endpoints, or the way we do VNet injection, we are bringing these PaaS services into the VNet. Containers is no different. We also want to do the same thing with containers. When you have a container, be it a container instance or be it a container cluster like AKS, we want to bring that right into the VNet. So the network policies that you have defined for the VNet just works with it, right? And when we are doing that, we also want to be careful that we don't have you go to Azure every single time that you want to do something different with the container. Because like I said, containers are very dynamic. They come up, they go down really fast within seconds. So every time they come up, if you have to go and configure security group rule or public IP address and say, give me this, and you talk to Azure APIs, that's a slower API, a slower method. So what we want to do is we want to give you the networking power, but the APIs for that is through your natural orchestrator APIs. So if everybody's using Kubernetes, just use Kubernetes APIs to configure networking for that. The underlying network infra will be Azure, but the orchestrator APIs can just be Kubernetes, and we're fine with that. And that's the way we think networking for containers should be done. So by bringing the containers into a VNet, we're going to have a container as a first-class citizen in the network, which means just like how a VM was able to talk to other things, a container can also talk to other things, right? Now let's see how we do that. That's what the rest of the talk is going to be. So before we go into how we do it in Azure, I want to take a minute to kind of show you what is there in the industry today. What do people generally do? So in this picture, what I'm showing you is a VM on a VNet with a NIC. This is very standard, right? Like, you just get a VM, you have a NIC, you have a private IP address, right? On this VM, you can just go and deploy Docker containers. And you can do it all by yourself, download the Docker runtime, build your Docker containers, go to the VM, just bring up Docker containers, right? And Docker even gives you default networking, right? And that's a default, one of the modes the Docker provides is called as a bridge mode. So in this bridge mode, all the containers that you deploy in the same VM can talk to one another. They have IP addresses that is unique only within this VM, right? You can use those IPs to talk to one another, but you cannot go outside. If you have to go outside, then you will have to use the VM's IP address, as I'm showing over here, and then look at that port number 500. So this is called as a NAT DNAT technology, where every time you go out, use a specific port number of the VM to go out. So this port right now is dedicated for this container, for example, C1, because 192.168.1.1 is going outside. I'm using port 500 for this traffic. So if container 2 wants to go out, I may use port 501 to make it go out. So I use this port redirection mechanism to have things go out. But this is kind of cumbersome because you don't give the container its full use of the ports. And doing the NAT and DNAT takes away the source IP of the container, so which means it takes away the richness and entropy. Not a good way. I mean, it works. I mean, you can do it as long as for your test workloads, but for real production, this will come short. But there's also one more mode, which is slightly better than that. That's called the overlay mode. Now, the overlay mode is also provided by Docker as well as by other networking plugins. If you're using like Project Calico or Weaveworks, all of these people give you an overlay network. What happens in an overlay network is, again, you have a VM, you have an EH0, and you have a NIC attached to the VM, right? And the containers are again brought up in the VM. And these network plugins provide an overlay network on top of that. So they have their own addressing mechanism for this overlay network. And every time when a packet goes out, they do an encap. So look at how the blue packet now turns over to the green packet, which is the 192.168.1.1, which was the IP address of the container that belongs to the overlay network, is encapped with the IP address of the VM, which is 10.1.1.4. Why is that happening? Right? That's because the 192.168.1.1 is not a routable IP address. You're using that just for identification purposes, but packets cannot be routed using that IP address. So it uses the VM's network interface and encaps it with the VM's IP address and then goes out. The goodness with this is all the ports are usable now, right? Because you're only encapping with the IP of the VM, but you're not changing the ports. So using the encap decap mechanism, you can make this overlay work. What's the downside? You have to do encap on the VM. That takes the compute resources, some CPU processing, which means your perf degradation could happen. You may not attain the best perf. Every time you do encap decap, I mean, it's very natural to expect that's going to add some lag to your processing. So which means that your perf will not be that great. Plus, you have to maintain the networking plugin and have a different way of addressing your containers and all that, right? So all this led us to build Azure CNI plugin. So what's Azure CNI? So what is CNI to start with? CNI is a container networking interface that is now owned by CNCF. That's the Cloud Native Computing Foundation, owns this project. It's a very simple way of providing networking for containers. It has specifications of how a network driver and how an IPAM driver should work, right? A network driver is really the interface that you give to the container, and the IPAM driver is an IP addresses that you give to the containers. So what we did in Azure is we did an implementation of this Azure CNI. And CNI is the most standard thing that is used by the Kubernetes community, right? If you're using Kubernetes for orchestration for your containers, the networking is usually provided by the CNI. They even ship a default CNI with Kubernetes, which is called as KubeNet, and we'll talk about that as well. And that's a standard, so we did the implementation of that, and the implementation actually creates a VNet bridge. So, and then it gives an IP address to each container that is routable. Now, something to note over here, look at this NIC over here. It has 4 IP addresses, IP0, IP1, IP2, and IP3. All these 4 IPs are routable in the virtual network. Have people know about the multiple IPs in Azure in a NIC? Have you played with that, anyone? Okay, some of you have, right? So when you get a NIC in Azure, you have to have an IP address. That's called primary IP address. But you can add more IPs to this NIC, right? You can do IP234. You can do up to 250 IP addresses. So for a single NIC, you can have like multiple IP addresses. That's what we do over here. So we give the NIC multiple IPs, and the Azure CNI registers itself as a network provider in this VM for the containers. So as and when the containers are coming up, it'll go and attach a vEth pair. It's called as a virtual Ethernet. So it creates a vEth pair, attaches that to the bridge, and then the bridge is attached to the ETH0, which means the packet goes out of the VM's ETH0 network interface, but each container gets its own vEth. And in that vEth is going to have its own IP address. Look at how we have given IP0 to the ETH0, which is basically to the VM, and IP1, 2, and 3 is given to the containers, right? Now, this is too powerful now because each container has a routable IP address. So I can go out with this IP address. I don't have to do any encap, decap. This is already routable in the network. and that's the real benefit. Now we will see how this is getting used in the different products that I showed you, which is AKS, ACI, and web apps, Kubernetes, and how you are able to use it and what's the benefits for this. That's going to be the next step. So this CNI implementation is so clean, it's actually open source. You can go to GitHub, look at the code, you can actually contribute to it, you can download it. There's a binary that is ready for you to download as well, and you can directly use it for even Docker containers. So if you say that, you know what, I'm not going to use Kubernetes for orchestration, I'm not going to use Mesosphere, I'm going to build my own container cluster, right? And I'm not even going to use any orchestrator. Maybe use Docker Swarm, or maybe you just have your own thing. Even then you can use your Azure CNI, because Azure CNI, all you need for Azure CNI is the VNet and downloading the Azure CNI plugin, right? And we have step-by-step instructions for you to download this. So you can use it just with Docker containers. You may have to do a lot of manual steps, but we have clearly documented them, and you can do that. Or if you're building your own Kubernetes cluster, so this is not the AKS path, but you say, I like Kubernetes, but I don't want to use AKS for some reason, and I'm not sure why, but let's assume you do that. But even then, you can do the same thing. You can download the Azure CNI plugin and make it usable in the AKS cluster. But the best and recommended approach and option for us is use AKS, because AKS makes it much simpler for you. Let's do a quick show of hands. How many people have tried AKS here, Kubernetes service? It's a good number. And for those who have not tried it, please go try that out, because what AKS does is it makes Kubernetes easy to use for you. I mean, it doesn't take away the power of Kubernetes or the easy approach with Kubernetes. It just does things for you automatically. So with AKS, we have an option that brings in the Azure CNI into the picture and gives you all the benefits. We'll look at that as well. So if you're just using AKS, there are two options for networking. There is a basic option, right, which is basically the default Kubernetes CNI plugin implementation. Like I told you, that's called KubeNet. And what it does is it provides IP addresses to each pod, but those are not routable IPs. It just comes up with its own IP address that is local just to the VM, and is used as a clever mechanism called user-defined routes. Right? Have you played with UDRs? People over here familiar with UDRs? Yeah. So UDRs is a very powerful way by which you can direct traffic into your virtual network. So they build a UDR, and they use the VM's IP address to navigate the packets between containers, right? So the goodness here is, like, you really don't consume IPs from your VNet, but it's a little bit cumbersome because there's a UDR in play, and if you want to take things under your control, you can't. And since the containers don't have a direct IP, they don't have the full connectivity, right? So what we did is we had an advanced mode for networking. So if you're doing AKS, networking has an advanced mode. When you select the advanced mode, now you're putting the AKS in an existing virtual network, right? You may have your VNet already set up with gateways and firewalls and whatnot, and on-prem connectivity and all that is working for you. You can just plug this AKS right into that VNet. And now Azure CNI also gets deployed for you. Now Azure CNI goes and creates many IP addresses on these VMs and provides one IP per container that becomes completely routable, right? And we'll see what all benefits it does. And this is how you actually do it in Azure AKS. In the UI, there is a clear option for network configuration, as you see over here, basic or advanced. You select advanced, then all you have to do is select a VNet and a subnet, and there you go. You get the IPs. We support up to 110 pods in a VM. That's a lot. So you can have 110 pods, each with its own unique IP that's routable. Now, on the VNet also, we have increased the limits. You can get 64,000 IP addresses in a VNet. So which means you can have like 64,000 pods in your VNet, each having its own routable IP address, right? Remember I said we want to really bring containers as a first class into the VNet. This is what we mean by that. Each container instance, right, and in Kubernetes we call it pods, so I'm using it interchangeably, pods and containers, but each pod now has a directly routable IP address, and it participates in the network just like a VM does. So what are all the benefits, right? Look at the connectivity benefits. So the minute I deploy this AKS subnet or AKS cluster into my existing VNet, I already may have VMs, VM scale sets, web apps, AD, right? the containers or the pods get direct connectivity between them. They can all go and talk to those over the IP addresses, right? And you can also talk to on-prem because you may have a gateway already on this VNet. So you can use that to go all the way to the on-prem. And if you have something running in the on-prem, that can talk back to these containers on this IP address. Now, you can talk to peered VNets. There may be other VNets that you have peered. Many people do hub and spoke, where you have resources in different VNets and you just peer them in a hub and spoke model. These containers now can talk to all of them, right? And the best part is you can also talk to other Azure services that may be locked by service endpoints. So if you have a storage account or SQL DB and you have locked it to a specific VNet, this pod now can go access that. Since the pod is actually in the VNet, all you have to do on the resource side is allow this VNet subnet, and the pod can go and actually talk to that. Right? So that's the benefit of connectivity. Now, NSG, now we can use some of the infra security controls to also make use of your pods. So you can put an NSG on this AKS subnet. So let's assume that all the pods over here, you don't want to allow any access on them other than 443, right? You can do that. So all you can say is only 443 is allowed from internet. Everything else is blocked. You define that NSG, you put it on the subnet, it gets applied to every pod. So every packet coming to the pod, this NSG rule will be like enforced. So that's a very good way to, I know there's some questions looks like, so we'll try to do the questions towards the end because we have a lot of content to cover. And we'll be here also after the talk if you want to grab us to ask any specific questions. So NSG, by using NSG, you can protect the subnet in which the pods are running, and if there's any rules that, let's say, your network admin wants to enforce that needs to be followed for your VMs as well as your pods, that's the place to do it. Now, it gets better. I can even bring Azure Firewall into the picture right now. If you want some enhanced FQDN-based filtering or a layer 7 filtering, and you want to use Azure Firewall for that, we just GA'd that product, by the way, yesterday. If you want to use that, no worries, right? Bring the Azure Firewall into the central VNet, then peer that to the VNet that is running the pods. Now set a UDR like that, which says, except for the public IP, because if we had direct public IP connections to your pods, make them go through the internet for return traffic. But any other traffic that your pod may originate and back to the internet or anywhere else, you can make it go through the Azure Firewall. So because of bringing the containers and pods into the VNet, all these benefits that you can leverage. One was connectivity. You are more well connected now. Second, you can use existing infra also for your pod workload, which is Azure Firewall is one of them, right? Let's keep looking. Now, load balancing. Now, this is a very important aspect of the container workloads because you want the containers to be load balanced, right? We offer you two options here. Now, this is a layer 4 load balancing, which is the Azure load balancer. This comes inbuilt at no extra cost with basic and a little bit of cost for standard load balancer. You can use a standard load balancer, and look, this is the real interesting part where the user, all he has to do is come up with a YAML file. He doesn't have to go and call Azure APIs to set up load balancing through Azure. Since he's running Kubernetes, he's comfortable with Kubernetes way of expression, you can come up with a YAML file and say, I want a load balancer on this IP address on this port. He takes the YAML file, does a kubectl control command to the master, and the Kubernetes master over there talks to the Azure load balancer in the background and sets it up. Now, the load balancing happens to all the VMs of the AKS nodes, and from inside of that, a kube proxy will distribute the traffic, right, to other pods. So very easily we are able to bring the load balancer to work with the pods using the mechanism, right? Now, one more, we also have ingress controllers. Now, Azure Application Gateway has just announced support for ingress controllers. If you want layer 7 load balancing, right, not layer 4 but layer 7, you can do something very similar where you come up with a YAML file and then you go to kubectl and then do it through the Kubernetes master, and the ingress controller will then talk to the Azure Application Gateway, sets up the pods directly as backends, and this works. Now, to have all this work for you, you have to use the advanced networking option for Kubernetes because that is what gives your pods direct routability, and you need that for such scenarios, right? So now with all that, I'm going to go to the demo, but before that I want to kind of share a quote that we got from our customer. AccuWeather is somebody who's been using AKS and advanced networking for quite some time, and this is what they had to say. I mean, by using Azure CNI, their connectivity got so much simplified because they were able to, from their pods, talk to the nodes which were running DB, which is in a different VNet, and that was peered to this VNet where the pods were running. And because of Azure CNI, they had full connectivity, and they were able to get their the scenario working. So this the customers have been really enjoying this option. So we just wanted to make sure that and this is not something new we are announcing in this event. This has been available for you for the last 3 months, I would think, in GA form. So go please use it. Now, I was going to do a demo, but I'm actually going to skip that and hand over to Anand, because another important aspect that we want to talk to you about is AKS and everything is about dedicated infra, right? Because it was your VMs and it was running the pods. So the pods and the VM can be in the same virtual network, right? But that may not be true when you use multi-tenant applications like ACI and web apps. So how do we do networking for that? So Anand is going to talk to us about that and more newer network policies. So Anand, please.
Thanks, Martin. Okay, so we basically looked at how NSGs provide security for the infrastructure. So if you have your Kubernetes cluster that you deploy in your VNet, in a subnet, and if you apply NSGs on that subnet, it's going to apply to all the entities in there. It's going to apply to the VMs, to the containers. So you have a uniform set of policies that are now applying to containers. But the container world is a little different. It needs fine-grained access control. In a typical cluster, you could have different namespaces. You could have maybe 5 containers running in one namespace, another 5 running in another namespace, and you might want to set up policies between them. You might want to say container in one namespace is not allowed to talk to the other one. Similarly, you could have containers sitting on the same VM, and you may want policies between them, right? So in all these cases, you will see that you need a different kind of mechanism, something that complements NSGs, something where you could say that NSGs apply to the subnet, but when it comes to fine-grained policies, I want a different solution. And that solution is the Kubernetes network policies, and I'm happy to announce that we now have an Azure implementation of the Kubernetes network policies. Kubernetes network policies basically provides you micro-segmentation for containers, just like what NSGs do for VMs. And we have implemented the specification as described in Kubernetes. What this allows you to do is it allows you to group containers based on labels. So labels are very powerful in Kubernetes, and you can now group them based on labels and define policies based on labels. You could have ingress policies, egress policies that decide what kind of traffic is allowed to come in, what's allowed to go out, who's allowed to talk to whom. All that can be defined with respect to labels. And the way to define it is very simple. You just create a YAML file, you define all the policies there. I have a sample right there on the top. And then you just apply that to your Kubernetes cluster. The policies get applied automatically. A few things to note about our implementation. The first is that it works in conjunction with the CNI, the Azure CNI. So while Azure CNI goes and provides connectivity to all the containers, we go and provision policies through the Azure Policy Manager. The Policy Manager actually goes and sets up IP table rules in the kernel so that the filtering can happen. So today we support only Linux hosts. Windows is coming soon. And there are 2 different ways in which you can use the Azure network policies. One way is to go and enable it in a cluster that you would bring up using ACS engine. It's a very simple setting. If you are familiar with ACS engine, you would know that there is something called a cluster definition file, and there is a setting in there called network policy. You set it to Azure, and you automatically have Azure network policies enabled. The other way to consume it is to build an AKS cluster from scratch, or rather a Kubernetes cluster from scratch in Azure. And once it is set up, you can pull down the actual policy daemon set and have it run on all the VMs, and you're all set to go. Now, I know that the AKS integration has been a top ask, and it's coming very soon. I'm expecting it to be here in a month or 2. Okay, so far we looked at scenarios where all your containers were single tenant. That is, you owned the infrastructure, you built the AKS cluster, or you built the Kubernetes cluster yourself, and you brought up containers in them. The VMs and the containers were both owned by you. They were both running in the same VNet, right? But that is not the model that a lot of the PaaS and SaaS services in Azure follow. We have a lot of services, for example, ACI, that have a shared infrastructure, and they bring up compute instances for every customer. So if you went and asked for an ACI container, right, you would have that container come up for you, and it is still sitting in a shared infrastructure. So you could get into a scenario where you have an infrastructure like this, where multiple containers of multiple customers are running on the same VM, right? And needless to say, we need to be able to go and inject all these compute instances, these containers into the VNets, into the respective VNets of the customers, so that you can go and access other workloads. Now, you might have used traditional injection mechanisms that we have in Azure today. For example, if you use HDI and you say that you want the HDI service, it automatically goes and injects the entire HDI VM allotted to you into your VNet, and you get VNet connectivity that way. That kind of an injection mechanism won't work here because we are trying to inject containers. The other drawback with that approach is that it is very top-down. That is, you go and say you want a service, and then the service goes and injects it. But in a containerized service, that's not how things work, right? I mean, it is a service that knows when to scale up and scale down your pods. So you cannot go about asking for networking or VNet attach for all your containers. So hence, it's not a very suitable approach. And also, it takes a long time, whereas we want containers to be fast. If you bring up a function, an Azure function, you want it to come up on a container quickly and get attached to your network fast, so that you can start running your workload on it. So with that in mind, we have come up with a few enhancements, a few critical enhancements to our SDN stack, which allows you to inject containers into your VNets very quickly. And this is a solution that a lot of services in Azure, a lot of PaaS and SaaS services in Azure are going and slowly integrating with. So I'll talk about some of the key aspects here. We have something called the Delegated Network Controller, which is a new component. And that component basically has a snapshot of all the different networks into which containers are going to inject. It's almost like caching all the network states, right? So whenever a container comes up, the service requests for networking directly from the DNC, as we call it. And the DNC basically allows an IP address, right? So the next aspect is the multi-tenancy. This new improvement that we have made allows you to go and run containers of multiple customers on the same VM. They could even have overlapping IP addresses. And the magic there is performed by the Azure CNI that you saw earlier. This is a slightly different version of that. It is a multi-tenant version. It basically picks up the IP address that it gets from the DNC, allots it to the container, connects it to the VNet. It does all the networking that we saw earlier. Additionally, it uses VLANs to actually provide isolation. So we are running a layer 2 network inside the VM. We have taken a lot of the networking into the VM to provide you multi-tenancy there. This is also a secure solution because you decide, you tell the service which subnet you want all your pods and all your containers and apps to be injected into. And the other advantage that it provides is that it separates the networking of the VM from the networking of the container. This is of great value add because if you look at services like HDI today, right, even if they inject the VM into the VNet, they want to be able to manage it, and then they come and tell you to configure NSG rules, open up firewall ports, etc., so that they can access their own infrastructure. None of that is required with this because only the container is now injecting into your VNet. So you have to only worry about your own containers. And it's multi-platform. We have support for both Linux and VMs and Windows VMs. And what this means is that both Linux and Windows containerized apps can be injected into the VNet in this fashion. Now, how do you actually use it? It's pretty simple. If you take ACI as an example, which I'll be going into more detail later, you first start off by creating something called a delegated subnet, and you say that that subnet is now assigned to the service. What that means is that only that service can deploy workloads into that subnet. You cannot add VMs or any other workloads to it. And then once you do that, you go to the service and say that I want containers or I want apps from this service. Please use the subnet that I have created for that purpose. The moment you do that, that subnet gets locked to the service. Only that service can use that subnet. Even you cannot go and delete it from the networking portal. You can delete it only if an unlock happens. That's it. With these two steps, you are all set. All the different workloads that you bring up in that service automatically get injected into this particular subnet, right? So this is an evolving stack. So we have a few capabilities now and a lot more coming later. Right now, when you go and inject a container or an app in that fashion, you can access other resources in your VNet. You can access on-premises resources. You can access resources that are protected by service endpoints. You can go to the internet, of course. And then if you try to publish your app behind an app gateway, that works. But if you do things like NSGs, UDRs, SLBs, VNet peering, that's not available today, but it's coming very soon. Those are very much in our roadmap, and those are enhancements that we are looking at. Okay. So with this, I would like to announce the availability of containers through Azure Container Instances being integrated into a VNet. So if you bring up an ACI container today, it goes directly into your VNet, which was not the case earlier. And ACI, as we call it, basically integrates with the stack that I described earlier. So let's look at some of the details about how the integration happens. So this is a diagram that depicts what we have today and what VNet integration gives you. So today, when you bring up an ACI container, it is running in the infrastructure of ACI. Every container that you bring up is very isolated. It gets a public IP. It is only accessible from the internet. Containers cannot even talk to each other unless you use the public IP route. So they are pretty isolated, and of course, they don't have any access to any of your VNet resources. But now with VNet integration, you see that command on the top right with that single command where you specify the name of the container, the image that you want to use, and the subnet and the VNet that you want to inject to. With that single command, you can now bring up a container directly into your VNet. And it gets an IP from your VNet. It is able to access other resources in the VNet like VMs. It can go on-prem, etc. And the beautiful thing about this is that when you create the container for the first time, it creates something called a network profile. And a network profile is something like a template. And the template contains properties or network properties of other containers. So when you want to bring up more and more containers into your VNet, into that subnet, you don't have to specify the VNet and the subnet information every time. You just specify the network profile, and boom, the container comes up in that VNet. So today, that particular template only has the delegated subnet as a property, but going forward, it gives us the flexibility to add a lot of pod or container specific policies. So if I want to set up route policies or security policies per container, I can do all of that through the network profile. And the command there at the bottom left side gives you the syntax that we use there to bring up containers using the profile. So web apps is the other service that is integrated into the modern stack. They're going to preview very soon, but I just want to take a few minutes to talk about it. So today with web apps, you specify that you want a web app server farm, and then you specify the number of different apps that you want to bring up. Once these apps come up, they are in the web apps infrastructure. Web apps actually sets up a point-to-site connection to your VNet so that the VNet resources can be accessed. But then if you have a service endpoint that is locked to the VNet, it is inaccessible over point-to-site. So that breaks a lot of important scenarios because customers with web apps want to go to storage, they want to go to SQL, all that was impossible today. But now with VNet integration, just like ACI, you drop the app directly into the VNet. The server farm is still in the web apps infrastructure. The apps are now running in your VNet, and you have full access like what we saw earlier. And this is going to be previewing very soon. It's going to be available for standard and better pricing tiers of web apps. With that, I'll actually show you a demo of how ACI works. Okay. So I'm going to start off by creating a container which will directly land into your VNet. Yeah. So this is the command I use. Right now, the interface that we have is CLI, and like the most popular interface that our customers are using with ACI. So as you can see, you specify the image, you specify the name, and then you specify the VNet and the subnet names, and that's it. It starts the deployment. It takes a few seconds. So while it's coming up, I just want to show you a few other things. So this ACI VNet that you see here is a VNet into which I am deploying all these containers. And there you will see two subnets. I have a separate subnet for ACI subnet, and that is where all your containers are going. And if you look at this subnet, you will actually see that it is delegated to ACI. I'm just scrolling down, and you see this portion, subnet delegation, and you can clearly see that it has been delegated to container instances, which is ACI. So that's what makes containers land into that VNet automatically, into that subnet. And that subnet has a 172.168.10.0 address space. And you'll see that when this container comes up, it will have an IP address from that subnet. So let's see if the container is up. Yeah, Hello World 2 is the container that I was trying to create, and yeah, you see that it has a 172.28.10.5. It has a VNet IP address. So there's another thing I wanted to show you. Let's take a look at the details of this container, right? Now, so this is a dump of the CLI output of the container. You will see the container Hello World 2 there, and then what you see here is the network profile that I was talking to you earlier about. So when you create subsequent containers into the same subnet, you can use this instead of specifying the VNet and the subnet every time. So let's now create a container that uses the network profile ID for specifying the network properties. So I knew the network profile ID upfront, so I have a ready-made command here. And here you will see that I'm still specifying a name, I'm specifying an image, but instead of specifying the VNet and the subnet explicitly, I have now provided the network profile information. And this is going to get started. So while this container is coming up, let's look at what I can do with the container that I already brought up. The one that you see in the screen right now in front of you, it's called Hello World 2, and it is basically running a website that if you access, you will actually see the ACI logo. So let's try accessing that from a browser. So I'm actually starting this browser on a VM which resides in the same VNet, but just in a different subnet. So you see that the VM is able to access the website that is hosted on that container. Okay, so let's see if our other container is now up. Yeah, Alpine is the second container that I brought up, and you see that it also has a VNet IP address. There are a few other interesting things that this portal gives you. If you go to the container section of ACI, you can actually look at all the events associated with that container. You can look at logs. You can actually even connect to the container, and that's what we're going to do now. So I'm going to open a bash shell on the container, and I'm going to try pinging the Hello World container that I created earlier.
$172, right?
Thank you. There. So now we are looking at a scenario where one container is able to talk to other container when both of them are in the same VNet. Okay. So now I'd like to just summarize what we have gone through, in this entire session. So there are a multiple set of capabilities that VNets provide you, and we are at different levels with respect to how much of that you can leverage from the different services. If you are deploying a single tenant Kubernetes service using AKS, or if you go and create your own cluster, then most of the capabilities are available. It is the injection scenarios like ACA and web apps which are evolving and where we have a little more work to do, and the places where you see the cross are the areas where we are investing. Those are all very much in our roadmap, and many of them will be coming very soon. We are actually expecting a lot more tick marks on that side of the table, maybe in the next 6 months or so. And then we have a lot of documentation online. I'd request you to go try it out and then provide us your feedback. And then also please evaluate this session.
Yeah.
If you have any questions, we can discuss that now. The previous one? I think the deck is also available to all of you, so you can just go there and click on all these links.
So everything we showed you as a detailed step-by-step instructions on these documentation pages and how you can do it, and many of it is also doable through portal, and there are a lot of sample scripts and all that. It should be easy to kind of use. So I think there were some questions. Yeah. Did you talk about the ASGs, security group stacks? Yeah. So we don't support the ASG directly to the pod yet, but it's something that we'll be looking into in the future as a good addition for what we can offer.
Yeah, so but you can actually still implement at the VNet level. I think that is, it is in the case of
on the subnet, on the VMs where the pods are running, you could do the tags on the VMs, but not directly to the AC instances if you're asking about that. I think we are out of time, but we will stay here and outside. If you have any questions, you can come and talk to us. Oh, you have one more? Yeah, let's go.
Can we do the static IPs for the containers or dynamic IPs?
So for the ACI or for the ones, so in both cases, you have control over the subnet IPs. So you can determine what IPs to give the subnet, and once you give the subnet IPs, then the containers will use something within that. But you cannot have a very specific IP in that subnet, but it will be one of the IPs that you give in the subnet.
So let's say we hosted an application on it, and that particular application is tied to particular IP address. Once the container is removed, the IP gone, right?
Yeah.
It's going to get a new IP.
Right.
So how are we going to improve that?
Yeah, so see, the thing is that, when you go into the world of containers, right, you are expected to play less with IPs and play more with labels. So the right way to bring up the pod in that case would be to say, when you come up, use this label, so that anytime the pod comes up, it will always have that label, and all the policies are defined with respect to that label. So if you look at the policy description of bringing up a container, if you look, it's typically a YAML file, right? There will be a section where you can label a pod. So if you specify that, the pod gets the label, and anytime it dies and comes up again, it will always come up with that label. So you should actually build policies that are label based.
Also, the service discovery that Kubernetes provides is pretty good, where the pods can be registered to a service name, and the automated DNS lookups is another way to do it, because containers come up and go, and a static IP and IP retention is not a great thing to have with container workloads. All right, thank you guys.